Lesson 5. Network Address Translation. In computer networking, network address translation (NAT) is the process of modifying IP address information in IP packet headers while in transit across a traffic routing device. Learning objectives: configure NAT rules on web and gateway servers. Network address translation. Network address translation (NAT) allows security administrators to overcome IP addressing limitations, allowing private IP address allocation and unregistered internal addressing schemes. Enterprises employ NAT for a variety of reasons, including private IP addresses used in internal networks, limiting external network access, ease and flexibility of network administration. Network address translation (NAT) can be used to translate either IP address in a connection. When translating the IP of the machine initiating the connection, typically the client of the connection, this is referred to as source NAT. When translating the IP address of the machine receiving the connection, this is referred to as destination NAT. The security gateway supports two types of NAT where the source and/or the destination are translated. Hide NAT. Hide NAT is a many-to-one relationship where multiple computers on the internal network are represented by a single unique address. This enhances security because connections can only be initiated from the protected side of the security gateway. This type of NAT is also referred to as dynamic NAT. Static NAT. Static NAT is a one-to-one relationship where each host is translated to a unique address. This allows connections to be initiated internally and externally. An example would be a web server or a mail server that needs to allow connections initiated externally. NAT can be configured on checkpoint hosts, nodes, networks, address ranges, and dynamic objects. NAT can be configured automatically or by creating manual NAT rules. Manual NAT rules offer flexibility because it can allow the translation of both the source and destination of the packet and allow the translation of services, IP addressing. In an IP network, each computer is assigned a unique IP address. Because public IP addresses are scarce and expensive, many enterprises choose to use private addresses for their internal networks. The following blocks of IP addresses were set aside for internal network use in RFC 1918, Address Allocation for Private Networks. Class A network numbers: 10.0.0.0-10.255.255.255. Class B network numbers: 172.16.0.0-117.31.255.255. Class C network numbers: 192.168.0.0-168.255.255. Best practices recommend using only these address ranges for intranets. RFC 1918 addresses cannot traverse public networks. Hide NAT. In Hide NAT, the source is translated, the source port is modified, and translation occurs on the server side. As shown in the illustration below, notice the source packet with address 10.1.1.101 going to destination x.x.x.x. As the packet hits the interface on pre-in, I is processed by the firewall kernel and forwarded to post-in, capital I, where it is then routed to the external interface. It arrives pre-out O and is then processed by the NAT rule base. The firewall modifies the source port and adds the port information to a state table. The packet translates on post out, capital O, as it leaves the gateway. For protocols where the port number cannot be changed, hide NAT cannot be used. Choosing the hide address in hide NAT. The hide address is the address behind which the network address range or node is hidden. It is possible to hide behind either the interface of the gateway or a specified IP address. Choosing a fixed public IP address is a good option if you want to hide the address of the security gateway. However, it means you have to use an extra publicly routable IP address. Choosing to hide behind the address of the gateway is a good option for administrative purposes. For example, if the external IP address of the gateway changes, there is no need to change the NAT settings. Static NAT. A static translation is assigned to a server that needs to be accessed directly from outside the security gateway. So the packet is typically initiated from a host outside the firewall. When the client initiates traffic to the static NAT address, the destination of the packet is translated. In the past, all destination NAT occurred at the server side of the kernel, that is, on the outbound side of the kernel closest to the server. When NAT occurs in this configuration, a host route is required on the security gateway to route to the destination server. As of VPN1 NGX, the default method for destination NAT is client-side, where NAT occurs on the inbound interface closest to the client. Assume the client is outside the gateway and the server is inside the gateway with automatic static NAT configured. When the client starts a connection to access the server's NAT IP address, the following happens to the original packet in a client-side NAT described on the next slide. Original packet. The packet from outside the gateway arrives at the inbound interface I destined for the web server and passes security policy and NAT rules. If accepted, the packet information is added to the connections table and the destination is translated on the post inside of the interface I before it is routed. The packet arrives at the TCP or IP stack of the gateway and is routed to the outbound interface O. The packet is then forwarded through the kernel O and routed to the web server. Reply packet. The web server replies and hits the inbound interface I of the gateway. The packet is passed by the policy since it is found in the connections table and arrives at the post inside of the kernel I. The packet arrives at the TCP or IP stack of the gateway and is routed to the outbound interface O. The packet goes through the outbound interface and is translated to the static NAT IP address as it leaves the security gateway O. The source port does not change. When the external server must distinguish between clients based on their IP addresses, hide NAT cannot be used because all clients share the same IP address under hide NAT. To allow connections from the external network to the internal network, only static NAT can be used. NAT Global Properties. Several global properties influence how NAT is handled by a security gateway. The figure shows the default global properties for NAT. In most cases, the security gateway automatically creates NAT rules based on information derived from object properties. The following three global properties can be modified to adjust the behavior of automatic NAT rules on a global level. Allow bidirectional NAT. If more than one automatic NAT rule matches a connection, both rules are matched. If allow bidirectional NAT is selected, the gateway will check all NAT rules to see if there is a source match in one rule and a destination match in another rule. The gateway will use the first matches found and apply both rules concurrently. Translate destination on client side. For packets from an external host that are to be translated according to static NAT rules, select this option to translate destination IP addresses in the kernel nearest the client. Automatic ARP configuration. Select this option to automatically update ARP tables on security gateways. For NAT to function properly, a gateway must accept packets whose destination addresses differ from the addresses configured on its interfaces. Automatic ARP configuration adds the ARP entries needed to accomplish this task. This property applies to automatically created NAT rules only. Merge manual proxy ARP. Select this option to merge automatic and manual ARP configurations. Manual proxy ARP configuration is required for manual static NAT rules. If a manual ARP configuration is defined in the local.arp file and automatic ARP configuration is enabled, both definitions are maintained. If there is a conflict between the definitions, the same NAT IP address appears in both. The manual configuration is used. If this option is not enabled, an automatic ARP configuration is enabled. The gateway ignores the entries in the local.arp file. Object configuration. Hide NAT. Hide NAT can be configured to hide networks using a security gateway IP address or another externally accessible IP address. The figure illustrates how to configure the NAT properties for a network using a security gateway's IP address when dynamically translated. To configure Hide NAT with automatic NAT rule creation, select the appropriate options and click OK, which automatically creates the necessary NAT rules for the object. Address translation rules are divided into two elements, original packet and translated packet. The elements of the original packet section inform a security gateway which packets match the rule. The translated packet elements define how the security gateway should modify the packet. Configuring the network object as described above creates two rules in the address translation policy. The first rule prevents translation of packets traveling from the translated object to itself. The second rule instructs the security gateway to translate packets whose source IP address is part of the corporate finance nets network. This rule translates packets from private addresses to the IP address of the exiting interface of the security gateway. Because Hide NAT also modifies source ports, there is no need to add another rule for reply packets. Information recorded in a security gateway's state tables will be used to modify the destination IP address and destination port of reply packets. Hide NAT using another interface IP address. Hiding internal addresses behind a security gateway's IP address is not the most secure way to configure Hide NAT. Using another externally accessible IP address for Hide NAT is considered best practice. The figure illustrates how to configure the NAT properties for a network that will use another externally accessible IP address when dynamically translated. For automatic NAT rule creation, the security gateway makes all necessary root and ARP table entries on the security gateway. In the example above, the security gateway will process packets destined for 172.22.102.15, even though that IP address is not bound to its interface. For routing to work properly, the address selected to hide internal networks should be on the same subnet as the IP address of the interface where packets will arrive. Like Hide NAT behind a security gateway's IP address, configuration for Hide NAT using another externally accessible IP address also creates two rules. The first rule instructs the security gateway not to translate traffic whose source and destination is the object for which HideNet is configured. The second rule translates the source address of packets not destined for the object for which HideNet is configured. Static NAT. Configuring a security gateway to perform static NAT for a host is similar to configuring a security gateway to perform HideNet using another externally accessible IP address. The figure illustrates how to configure NAT properties when static NAT is used to translate a host's IP address. For routing to work properly, the translate to IP address must be on the same subnet as the security gateway's IP address. When automatic NAT rule creation is used, it makes the necessary adjustments to the ARP configuration. Configuring an object for automatic creation for static NAT rules adds two rules to the address translation policy. For static NAT, both rules are translating rules. In the example above, the security gateway changes the source address from a private address to the public address. Manual NAT. The security gateway allows security administrators to create manual NAT rules. Manual NAT involves more configuration than automatic NAT rule creation, but provides additional flexibility in rule-based design. Automatic NAT rule creation is appropriate for most installations. Properly configured objects, well-planned networks, and global properties settings make manual NAT rule creation unnecessary for most enterprises. For security administrators faced with legacy networks where design issues prevent the use of automatic NAT rules, manual NAT rules may provide solutions. Some of the situations where manual NAT rule creation may be warranted include instances where remote networks only allow specific IP addresses, situations where translation is desired for some services and not for others, environments where more granular control of address translation in VPN tunnels is needed, enterprises where address translation rule-based order must be manipulated, when port address translation is required, environments where granular control of address translation between internal networks is required, when a range of IP addresses rather than a network will be translated. Configuring manual NAT. Manual NAT requires configuration of objects and rules. The amount of configuration varies between HideNet and static NAT. Global properties for manual NAT rules. On the NAT window of global properties, only one global property can be set for manually created NAT rules. The translate destination on client-side property performs the same function for manual NAT rules as it does for automatic NAT rules. Translate destination on client side. For packets from an external host undergoing static NAT, translate destination IP addresses in the kernel nearest the client. Enable IP pool NAT. If IP pools are used on a gateway, secure remote or secure client connections are modified, so a target host sends reply packets to the appropriate gateway. When automatic NAT rule creation is used, it makes all necessary adjustments to the security gateway's ARP and routing tables. Using automatic NAT rule creation also eliminates potential anti-spoofing issues. If manual NAT rule creation is used, special consideration must be paid to ARP and routing table entries and anti-spoofing issues. ARP. When automatic NAT rule creation is used, the security gateway makes all necessary adjustments to the security gateway's ARP table. If manual NAT rule creation is used, the security administrator must edit the security gateway's ARP table as follows. HideNet security gateway in translated packet source field. No additional ARP table entries are required. HideNet Hiding behind an IP address not assigned to the security gateway. Add an ARP table entry to the security gateway for the hiding address. Static NAT. Add ARP table entries to the security gateway for all hiding addresses.